thing in A that says copper 2 sulfate solution? Not copper 2 sulfide, is it? Copper 2 sulfate. And if I know anything about my solubility rules, the other day I gave you one more solubility rule to make number 4. And that is sulfates are generally soluble except for what 5? Calcium, strontium, barium, silver ion, and lead 2 ion. Okay? So, copper 2 sulfate soluble. 100% soluble. Unit 2. So let's look at what that looks like. So I'm not looking at this question at all. Right now, for just a quick moment, I just want to stop and say, let's look at a quick review of copper 2 sulfate dissolving in water as we learned about back in Unit 2. When things are 100% soluble, it means that they break up completely 100% into their ions. Isn't that what soluble means, 100%? Okay, so if I'm starting with 0.02 molar copper 2 sulfate, in the very beginning, before it dissolves, there are no ions. So we would call that the initial. What are we going to see in the change? We're not going to see X's. It's 100% soluble, Matt. So how much of him dissolves? All of it, minus 0.02 molar. All of him dissolves because he's completely soluble. So Austin, how much copper ion do I make? .02. 0.02. And Michael, how much sulfate do I make? Same amount. Why the same amount? Coefficients are the same. Their coefficients are the same. So instead of doing minus x plus x, when I don't know how much dissolves, it's minus 0.02 plus 0.02 plus 0.02 because I do know how much dissolves. All of it. And then I look at those coefficients to know how much of each ion do I have when it has all completely dissolved. And I just use coefficients to help me decide that. So, glad you asked, Michael. So now, what in the world does that have to do with copper 2 sulfide? There's a common ion present when you're trying to dissolve copper 2 sulfide in a copper 2 solution. You already have some copper 2 ion at the initial spot. So it's not 0. That's the only thing that makes it different. It's not 0. It's 0.02, which changes the solubility. It's not pure water any longer. It's a copper 2 ion solution. So let's move this guy over. Let's tell it to get rid of all that. That's just review. But what this means right here is that I have 0.02 molar copper ion already present, and I'm trying to dissolve copper 2 sulfide in him. It limits how much copper 2 sulfide can dissolve because there's already copper floating around. Sulfate, spectate. You don't worry about sulfate. He's not the common ion. It's only the common ion that you worry about. So it's only this guy. You can just do this. It's only the copper 2 that you worry about. So we have CuS trying to dissolve in equilibrium with his ions once we allow it to reach equilibrium. We start with no sulfide ion, but we start with 0.02 molar copper ion. That's the only difference. That's the only difference. We're still going to come over here and put Z. And since it's an insoluble substance, Jordan, what are we going to stick at our C's? Minus X. We're going to go minus X. We're going to go plus X. And we're going to go plus. Thank you. So see, nothing has changed when you have a common ion except what you put right here. Now it's going to change our math. But that's all that's changed in my ice chart, if you will. So I get Z minus X. And what do we do with that? We say it's approximately Z. So, Kyle, 0.02 plus X is about what? 0.02. And 0 plus X is X. You mean we get to ignore the plus X under the common ion? Yes, and let me tell you why. The X that we found back in number 1, the value was 1 times 10 to the minus 18. Nyreek, if I try to take 0.02 and add 1 times 10 to the minus 18 to it, is it really going to change 0.02? So why don't I just make my life a little easier and ignore it? Math-wise, would you like that? Okay. So follow my yellow brick road. Follow what I'm doing. And do it too. So, KSP, which is just going to be copper times sulfide. 1 times 10 to the minus 36 is 0.02 times X. So instead of it being X squared like it was in question number 1, it's now 0.02X equals 1 times 10 to the minus 36. Don't you dare pull out a calculator. Don't need it. Don't need to, because I want to teach you something. Goes away, right? But if I do that, I got to do it to the other side. But let's change it when we put it on the other side to 2 times 10 to the minus 2. 2 times 10 to the minus 2. Isn't that the same as 0.02? Now, why do I want to do it that way? Because I want to do a little bit more mental math with you. What's 1 divided by 2? What's 1 divided by 2? 1/2. So 0.5. What is 10 to the negative 36 divided by 10 to the negative 2? And if you don't know yet, remember it's negative 34 minus a minus 2. Sorry. I'm jumping you to the answer. Sorry. Negative 34. There's my X. You might say, oh, that's not right scientific notation. Then fix it if you don't like it that way. 5 times 10 to the minus 35. Moles per liter. Is it always going to be moles per liter, Miss Patty? Yes. Yes, if you're finding X, it's always going to be moles per liter this time. Yes, sir. Would I? No. Would they be same people? No. Yeah. No. Okay, so question. We went from, in pure water, X was 1 times 10 to the minus 18. With a common ion, X is 5 times 10 to the minus 35. What happened? It got a whole lot smaller. When you've got a common ion present, it can't dissolve as easily. When you have a common ion present, it can't dissolve as easily. It's like on pep rally day, when we all go down to the gym and the gym's empty, we can all fit in the gym, right? But if we all go down to the gym on pep rally day and Brandon Middle School hasn't told us that they're over here, we can't all fit in the gym because of fire laws, right? Correct? It's that same concept. All of us can fit in the gym when it's pure water. But all of us can't fit in the gym when we go down there and there's already people in the gym. There's already copper in the gym. So not as much copper 2 sulfide can fit in the gym. That's what it's like. Okay, look at number 4 and see if you can, not number 4, excuse me. Letter B with me. Letter B. We're not quite to number 4, Ms. Matney. We're jumping the gun. Letter B. What's the common ion in letter B? Sulfide. Not the sodium, but the sulfide. So in letter B, it says, okay, what's the solubility when you've got this molarity sodium sulfide? Sodium sulfide. Now, one more quick little tidbit review. Let's go back to Unit 2 for a moment. Here's the formula for sodium sulfide. Sodium sulfide contains sodium. And he's one of my 4 always soluble cation ions. Do you know that? Thank you. All right, so you get 2 sodiums and 1 sulfide. So you have 0.01 molar of him. And when you're first trying to get him to dissolve, you say there's no ions. That's your I. Your C, which I didn't emphasize the E part on the other one before. It's an ending, not an equilibrium. Because we're not going to equilibrium, we're going to an end where somebody's 0. Stephanie, what do I put underneath my 0.01 if it's all going to dissolve? All of it's going to dissolve, not just some of it. Minus 0.01. Alyssa, what do I put under the Na plus? I did. What do I put under the Na plus? And Austin, what do I put under sulfide? 0.01. Did y'all realize you're doing stoichiometry right here? You're doing real life, review old stuff stoichiometry. So this is nothing left at the end. This is 0.02 molar left at the end. And this is 0.01 molar left at the end. And the only part of this that even matters for my problem up here is the sulfide. Yes. It's sodium sulfide. And sodium is soluble with everybody 100%. That's why I have an ending and not an equilibrium. If it's insoluble, it's going to be equilibrium. If it's soluble, it's going to be an end and 1 arrow. So yes. Okay. Now, that was all to help us do the review part. So now what we do is we focus on the fact we've got 0.01 molar sulfide common ion present. So how much copper 2 sulfide is going to dissolve? I don't know. We've got to find out. It's X. So we say this in equilibrium with copper plus 2 and S minus 2. This is 0.01 molar. This is 0. This is Z. This is minus X. This is plus X. And this is plus X. So at equilibrium, because of the double arrow, we have Z minus X, approximately Z. We have X. We have 0.01 plus X. But what do I get to do right there, Kyle? Right here. Thank you. I get to do that. I get to do that. You know what Christina, our exchange student, said? She said, but that's a lie. She's right. And we're lying twice. We're lying twice for Nyrik's sake because we don't want to do that ugly math. But we're allowed to lie. Yeah. Which is so cute, so innocent. But that's a lie. She said it as serious as she could be. And she was 100% right. I said, it is a lie. You're right. She is a lie. It is a lie. You're right. All right, so copper sulfide equals X times 0.01. Since I didn't put the value down, let's write it over here. 1 times 10 to the minus. Oh, I did write it over there. Never mind. I just didn't call it KSP. Okay. So, no calculator. You don't need a calculator. That turns into this. 1 times 10 to the minus 36 divided by 1 times 10 to the minus 2 equals my X. What's my X? What's my X? Thank you. See, 2 days ago, you didn't know how to do that, some of you. And now you do. Now you do. Moles per liter. The molarity, how would I turn it into grams per liter? Multiply it by molar mass.